Hey, hi everyone. Good evening. Good evening. Welcome to Cat Ninjas. Welcome to Cat Ninjas. I hope everyone is doing good. All are ill and healthy, and wish you all a happy Gandhi Jayanti. Fine. Let's get started with quant learning. So we will continue with the thing what we stopped in the previous lecture. Let's get started. But before we start, why don't you guys let me know whether I'm clearly audible? Let me also check meanwhile at my end. If the things are fine. Yeah, meanwhile, you can post as well. Yeah. All right. Good evening, friends. Good evening. Good evening. So let's get started. So meanwhile, let me introduce myself. Hey, this is Belvi Srinivas. I've been working in this industry since 2007. That's about 14 years now. So yes, in the 14 years, I did develop few skills to train the students effectively in the areas of QA, DI, and LR. Yes, I worked in various capacities with the various organizations. Sure, all right. So let's as we travel together, I'm sure, all right. So you would get benefited by the little things that I share with you. And in case if you are looking at any short counseling, so you can always reach out to me using this Telegram channel. So get into this particular, subscribe to this particular Telegram channel from here. Yes, you can reach out for short counseling, the short suggestions or short interactions, or it could be posting your doubts and asking for some tips on that particular doubt, the hints on the doubt, solving of the doubts, whichever way. All right? In any short format, the discussions can always be encouraged on this particular Telegram channel. Great. So that's about the background and how we can interface and work together as we go along. Yeah. So may I quickly know who are all in the meeting? If somebody is in the meeting, yeah, just let me know meanwhile. That would be nice. Okay, Devanshu. I could see Devanshu being there. And anybody else, or is it system hang? Or all relaxing because it's Gandhi Jayanti? Ritvik is here. Good afternoon. Good evening. Priyansh is here. Great. All right. Okay. Meanwhile, as you guys log in, just let me know who is coming in, who is going out. Right. Okay. So here we go. Of course, you can't let me know if you're going out. So makes sense only when you get in. Yeah, let me do quick announcements as we go along. So, Unacademy offers two kinds of subscriptions. One is Plus, the other one is Star. Star is nothing but iconic. Yeah, Plus subscription gives you the structured courses at various difficulty levels based on your learning abilities and at what stage of learning that you are. Some of them are positioned at level 1 of learning, level 2 of learning, level 3 of learning, various levels of learning, be it with respect to quant, DI, LR. So within quant, different modules. So you will get structured. That's what we mean by the structured courses. Different educators launch different kinds of courses to suit the different needs of the students, and the batches would generally commence, but there will be plenty of batches at any point in time. So whatever the 2 or 3 batches that suit you, you can always be a part of them. Right. And along with that, you will also get weekly tests and you will get some study material. So this is what you get access to as a part of Plus program. And as a part of Iconic, in addition to whatever you are getting from Plus, and in addition to that, you do get one-to-one interaction facilitation, right? So one-to-one interaction is you can interact. So what interactions? So interactions can be with respect to your B school admissions, your B school preparation for the interviews, or it can be form filling assistance, or it could be in the areas of test analysis, how to improve those extra 20 marks or 30 marks, how do I get them in the test, right? Or it could be a study plan because you might be based on your own swaths, your study plans could be slightly moderately different. It is not that one size fits all. So we all do things differently, but we all can excel. But it's not that I can copy somebody and it works. No, definitely not. We are all doing a little differently. Those little things can be kind of discussed with your mentors, so on and so forth. That's what Iconic does. Yes, on the Plus, these are the nominal prices or the Plus subscription. Yes, of course, there are Plus subscription for 2 months as well, 3 months as well. You can take a look at offerings. So generally, the 6 months, 18 months, 24 months is preferred for 21, 22, and 23 students. And on all this, you will get 10% discount when you use any of the educator code, including my code, which is Belvi 100. Yes, so if you are looking at CAT 21 and planning any subscription, I would rather recommend a 6 months iconic plan for a simple reason that you might require quite a bit of one-to-one interactions with at least a couple of people. So that enables, right? Iconic gives you that feature. So that makes quite a bit of sense. And along with all of this, yes, you will get these mocks free. You don't have to purchase them. Whether if you are enrolled for Plus or you are enrolled for Iconic, you get this mocks free. And writing mocks is very important. Tomorrow is Sunday. You got to ensure that you write a mock definitely on Sunday. Right, one on Thursday and Friday, one on Sunday is a must going forward. It's a must. In fact, it was must from previous month itself, but if you have not followed it, ensure that you at least follow it this particular month before it's late and you repent that, okay, I should have done it. So let's not get into that repentance. Rather, let's excel by following certain things. Yes, as a part of this MBA 21 mock series, you will also get 2 full-length mocks per week, 3 sectional tests and OMET tests and video analysis of all these mocks, etc. Right, yeah. So here is one of the offerings. There is a 2 month subscription that's kind of available. Yes, it's available even now, not just till 30th of September. 2 months subscription, so that's available at a nominal price, and some of the good educators have launched some of the revision courses, and you can kind of take a look into that as well. Okay, so meanwhile, so who all have joined? Can we exchange quickly some greetings? Who is there in the meeting? Who is? Can you quickly let me know? Rishav has joined. Sahil is here. Sumit is here. Okay, Devanshu, Ritvik, Priyanshi. Who else? Can I know the names if you guys are here? Why don't we exchange some greetings quickly? Yeah, yeah, Devanshu Singh, I read you. Good evening, good evening. Why for some people it is still afternoon? Sahil has actually texted afternoon. Priyanshi texted afternoon, right? So it's okay. It's okay. I mean, it's like a cast. You can say afternoon also, evening also, but somewhere I mean like so it's still afternoon, which means you're looking deeper into the evening as evening. Is it something like that? Because Ritvik also said afternoon, right? So I don't know. Hmm. All right. Hmm. Okay. Okay. All right. All right. Okay. Fine. Got it. Let's get started. Let's get started. Nice. Harish Khanna is here. Good. Fine, guys. Let's continue with where we stopped. All right. Where we stopped. Let's continue. I'm not going because I hope all those guys who are here. I saw you guys yesterday. Okay. Yeah. So we are here technically on the grouping. We said yesterday that we are here similar to different, and we kind of looked at the concept that how this technically falls into n factorial by p factorial q factorial. It falls into that kind of scenario. What we do is we will try and explore few question types based on this so that we kind of get comfortable with this kind of model. So let's try and spend some time and see that what are the different question types, because that is what we are supposed to be doing today, because the concept of this explanation was already clear yesterday. All right, so let's jump into this. The other types we will try and see when do we cover the other types. What is the importance of that we will see in few other lectures. All right, yeah. So here we go. So let us start with a quiz. Let us quickly start with a quiz. Why don't you guys answer this? Start by answering. This is based on yesterday's topic. Simple question from Cat as it is. Why don't you guys answer this? Let's start from here and then we will build. We'll build on it. Start this. Everybody start this. Direct question. This is pretty direct question. Everybody who attended yesterday's lecture should be able to answer. Very direct question. Go ahead, answer. Everybody keep your pen, keep your book. Don't be passive onlooker. Don't keep looking at the screen. Work along with us. Yes, guys, I'm extending time. I want answer. Everybody, type in the answer. Type in the answer. Cold start. I know some of you may be grabbing your books and pens and papers. Grab it, grab it. This is the time. All of you grab it and type the answer there. Put the answer. It's a very simple question based on what we discussed yesterday. I'm not still getting into today. It's only yesterday. Others, I could see only something from Ritvik, Sahil, Harish, and Sumit. What's happening with others? Priyanshi, Rishav, Sahil. Okay, Sahil has answered. Okay. Devanshu, where is your answers? Harish. Harish answered. Okay. Hmm. Why, guys? Only four of you answered. Okay. All right, so here we go. The number of ways in which 21 rupee coins, so which means identical, right? 21 rupee coins can be distributed among five people such that each one gets at least three coins, right? Among how many people? Five people. Give them the names A, B, C, D. Let's give them the names. So these are the five folks, right? So therefore, together you have to distribute 21 rupee coins among them. This is what the task is. They're identical objects, 20 identical objects to be given, distributed among five people. Give some names A, B, C, D, E. So, but each one of them should get a minimum of three. That is what author said. Hey, A should get three, B should get three, C should get three. Likewise, each one of them are supposed to be getting three. So, what do? Give three. Call A, call B, call C. Assume that they are sitting right in front of you. Call each of them and give three to each one of them. So, three are given, which implies 15 have been given out because you are not in control. We said that every equation to be brought to the position of greater than or equal to zero. Only then concepts should be applied, right? Whatever the concept that we discussed, p factorial, n factorial by p factorial, q factorial, you can apply only after bringing the condition back to zero. So since you brought the condition back to zero, you are left with only five objects. You are the boss on these five objects. So therefore, 5x's, you have 5x's, how many y's? 1, 2, 3, and 4. These pluses are nothing but the separating lines. Therefore, you have 5x and 4y. Together, you have 9 factorial by 4 factorial and 5 factorial. Yes, upon simplification, it results in 126. Your answers are correct. Okay, your answers are correct. I'm hoping it's very simple question to start with. I'm assuming that we all got a hang of this. So yeah, anybody who has seen this question before, this cat question, because multinomial, how many terms are there in the expansion of this multinomial, right? Like binomials, we have multinomial, more than two. We can call it as kind of a multinomial. Binomial is also a part of multinomial. How many terms are there in the expansion of x plus y plus z raised to power 20? Yeah, go ahead, guys. Try it for a minute. Try it for a minute. How do we go about this? Popular cat question as it is. Number of terms. What is the first option? The first option is 22p20. Right? Second option is 22c20. Right? Likewise. Yeah, read options carefully. Font size is a little up and down. Yeah, fine. Good. Listen, everybody listen, everybody listen. So where this concept is coming from, assume that if you are solving a binomial, what if I am solving x plus y raised to power 10? Assume that, okay? How many terms are there? If I ask you number of terms, what I want? I want the number of terms in the expansion of x plus y raised to power 10. So how do you start expanding this? You would say that, hey, this is 10c0, that is the coefficient. Then x raised to power 10 and y raised to power 0. This is the first term of your expansion, right? This is the first term. Second term, you would write this as 10c1, x raised to power 9 and y raised to power 1. Third term, you would write it as 10c2, x raised to power 8 and y raised to power 2, and so on. And finally, I'm writing in the order, isn't it? So therefore, you write it as 10c10, x raised to power 0 and y raised to power 10. Now, terms are always separated by plus or minus sign, as we all know. What is this here? This is the, so therefore, if you look at every term, look at every single term. Every single term has a coefficient. It doesn't matter. The coefficient can be 10c0, 10c1, 10c2. Doesn't matter. It has a coefficient. Technically, what does each term has? Each term has a coefficient, and there is a power of x. There is a power of x raised to some power a. A can be 10, A can be 9, A can be 8, whatever it is, A. And then there is a power of y which is raised to power b. That b can be 0, b could be 1, b could be 2, so something like that. Okay, so but then every term has this configuration. In this configuration, leave this coefficient. Coefficient is some number, but there is some static component of this particular part. What is static component? We always know that a plus b adds up to 10. Go to any term, you always observe that a plus b adds up to this particular power, which is 10. X plus y raised to power 10. Every particular term is already now the power, solid x plus y, that is static. Rest is dynamic. This is static. This is static means what? The sum of these two numbers is static. A plus b is equal to 10. Here, it's 10 plus 0, right? 9 plus 1, 8 plus 2. Finally, towards the end, 0 plus 10. So every configuration or at every term would have a different configuration of this a and b. A is the power of x, b is the power of y. Every term would have a different configuration. Therefore, it is pretty simple. How many configurations are possible for a plus b is equal to 10? How many ways I can distribute this 10 between a and b? So every configuration is nothing but a single term. So and hence you would solve this, you will say that, hey, this is 10x is here. Okay, x and y you are already using. Let me write it as p. There is, let me write it as m. Otherwise, there is 10m and there is 1n. Alright, therefore, you say the total answer is 11 factorial divided by 10 factorial, which is nothing but 11. That's your answer. In this case, you are trying to say that in the expansion of this, there are 11 terms. There are 11 terms. What is that? We are focusing on the static portion. There is a static portion. The sum of the powers always adds up to that required power, which is 10 in this case. It's a static portion. Apply the precisely the same thing in the expansion of x plus y plus z raised to power 20. How does each term of this particular expansion look like? Each term of this expansion would be, there would be a coefficient. That is another algebraic study. How to write the coefficient is another study in itself. So let's not deviate to there. It will simply take another 10 minutes for us to learn. But anybody who has done 11th standard math should not have a problem to understand how to write a coefficient of every single term. If I randomly ask you the coefficient of this, so you should be able to give that. Not able to give that, don't worry about it at this point in time. That's another part of algebra which we will learn, right? Okay, so there would be a coefficient. X would be raised to a particular power called a, y would have a certain power b, z would have a certain power c, in which a plus b plus c would be equal to 20. Some of these fellows should be equal to 20. Therefore, you are saying that how many configurations are possible such that a plus b plus c is equal to 20. Every configuration gives you a different term, right? So therefore, you have 20 x's, which means again, can a be 0 here? Why not? Can b be 0 here? Can C be 0 here? All simultaneously cannot be 0, just like we observed in the beginning. So here, all right, now y was 0 here, all right, there was no problem. So when you came somewhere towards the end, x was 0 here. So therefore, zeros are allowed. So it is already meeting the standard requirement. And hence you say that, hey, you have 20 objects, that is 20 m's to be distributed into these three, that there are two n's, and hence you say that the required answer is 22 factorial divided by 20 factorial and 2 factorial, which can be written as 22c2, or it can be written as 22c20, or you can simplify and give the answer. Therefore, the appropriate answer is option B, right? Because I don't see 22c2, 22c20 is what we see. Now I have a question here. How many terms will be there in the expansion of x minus 2y plus 3z raised to power 20. What is your answer, friends? What is your answer? Find the number of terms in the expansion of x minus 2y plus 3z. Answer. How many terms are there in the expansion of x minus 2y plus 3z? Yeah, you understood the full background of this story. Now my question is this. How many terms are there in the expansion of x minus 2y plus 3z raised to power 20? Answer. What's the answer to this? X minus 2y plus 3z. Number of terms in the expansion of this. Number of terms in the expansion of x minus 2y plus 3z. 3z. Quick answer. Everybody answer. How many terms in the expansion of this? Right? Same as the previous question, right? This is same as the previous question. What is previous question? It's the same answer. This is the answer to this. It doesn't matter whether the terms are separated by plus minus coefficients keep changing, right? That's what we discussed. See, while telling this problem, I told you what keeps changing. The coefficients will change. The terms are always separated by a plus sign or a minus sign. So therefore answer is pretty similar. This is exactly the working. You look at this and you work exactly like this, which in turn would be like this. That's it. So therefore this whole working would remain as it is. Okay, are you all clear on this? Guys, comfortable making sense? Are you all clear? Are you all clear what I'm talking? The terms are separated by plus or minus sign. Doesn't matter. And whatever the coefficients will add, all right, this will help this all right, this would ensure this would only change the coefficient part. Terms won't change. Number of terms won't change. Clear? Everybody clear? Clear what we are discussing? Is this clear? Right? Okay. Fine. Yeah, all those who did 11th standard math should be able to answer this. How many ways, at most, 9 identical marbles can be distributed among 3 children, A, B, and C? Take a minute. Everybody take a minute and think about this. Everybody take a minute. So anybody who has done the 11th standard math naturally you would have one chapter by name permutation combination. You should be able to answer. Not done 11th standard math, sure we will discuss. Otherwise also we will discuss. But I expect that there are quite a few of you who has done 11th standard math. You should be able to answer this. Go ahead, try your hands on this. Right? Okay. So what does it mean technically? Fine. Let's discuss. That's good enough. That's a reflection time. Good reflection time. You thought about it. So the word is at most 9. Assume that, okay, I have given you 9 marbles. You wish. I said that at most 9 marbles. I'm not pushing you saying that all 9 you should give. This time, what you meant is assume the 3 children A, B, C. So you are saying that, hey, I will give no marbles to these kids. I will keep all 9. I'm fine with it. I'm fine with it. You decided not to give. So therefore, this is one case which you can do. I'm fine with this because I said that at most 9. You decided I will not give anything to anyone. I'm okay, right? Don't give because I said this time at most 9. I didn't say that how many ways 9 identical. I'm absence of this. How many ways 9 identical marbles can be distributed? Then there is only one equation. A plus B plus C is equal to 9. This is what I was saying. But this is not what I'm talking now. I'm saying that at most, right? I'm saying that at most. Guys, yeah. Right? However, what I'm saying here is at most. Therefore, 0 is fine. Case 2, when you are looking at case 2, A plus B plus C is equal to 1. You decided that I will give one marble to these fellows. Point is to whom you would like to give. So therefore, I will find the answer to the second case. There is a third case. So you would say that A plus B plus C is equal to 2. Decided to give 2. To whom you will give this 2? Would you like to give 110 like this? Right? Yeah, something like this, right? Therefore, this is what you are kind of trying to say there. This is the case 3. Likewise, you would have a final case which will also say A plus B plus C is equal to 9. This would be the 10th case. So answer to 10 cases is what I am supposed to be finding out. These are 10 cases. So I'm looking for answer to all the 10 cases. Hey, first case can be done in some ways, second case can be done in some ways, third case can be done in some ways. Fair enough. So answer to all these 10 cases is what I need to find, add them together, which becomes the answer. This is what the meaning of the word at most 9. This is what the meaning of the word at most 9. When I meant at most 9, this is what we are kind of trying to evaluate. Nothing but, now listen, what you do, keep yourself in the game. This is called as introducing dummy variable, because it's a part of algebra also, right? Introducing a dummy variable. I will say that dummy variable is you. Keep yourself in this game. So I am pretty solid. If you put yourself in this game, all these 10 together can be written as, listen carefully, A plus B plus C and U, including U. This U is the dummy variable, which will be equal to 9. So when I say that where are 9 marbles, if you say that, I will take the first case. Hey, I've given I've decided to give them 0, fine. Then this is the answer to this equation. This is one of the ways of dealing with the case 1, because I'm saying that put yourself also into that particular game, because if you are not giving to anybody, then it is with you. All right, then it is going to be with you. That's the meaning of this. Hey, you gave 1. You gave 1. To whom you gave 1? I'm just explaining the second case. To whom you gave 1, right? A dummy case. To somebody you gave 1. Let's say that, okay, you gave 1 to B, which implies that A and C are zeros because you just gave 1. So then where are the remaining 8? It is with you. It is with you. That is the sum. That's the equation what you are talking. Okay, coming to the last case, A plus B plus C is 9. I am talking about this. There are many distributions. I'm just giving you one distribution of this 9. Hey, out of this 9, this fellow you gave 4, this fellow you gave 3, this fellow you gave 2. This is one distribution of this 9. How much do you have therefore? 0. All right, because if you are giving 9 to others, then you are left with 0. And hence, so instead of solving these 10 cases, we introduce a dummy variable. Introduce yourself. So otherwise, it was an inequality. When I spoke about this at most 9, what I meant here was this. Hey, A plus B plus C is less than or equal to 9, but it should be greater than, or it should be greater than or equal to 0. I was asking you to solve this. This is what I was asking you to solve. Solving this means writing these 10 cases, which is also nothing but writing it, introducing the dummy variable. Guys, is the word dummy variable clear to everyone? Introducing dummy variable, is this clear? Whenever there is an inequality, you got to use the dummy variable. Clear here? There is an inequality. Earlier it used to be an equal, but this time at most, at least means what? Unequal. Whenever there is an inequality, you can bring it to equal by using a dummy variable. Clear? Concept clear? Concept clear? Everybody, concept clear? This is what was given. This is what was given. So I wanted answers to the inequality A plus B plus C lying between 0 and 9, including 0 and 9. That will result in 10 cases, but I decided I don't want to write 10 cases. Then you introduce a dummy variable and write one case. Introduce a dummy variable and write one case. Guys, other than Ritvik, Rishabh, Sumit, Rutvik, others are also clear what I'm talking. Others are also clear what I'm talking. Is it making sense? Fast respond. Good. Okay. Avyav, Devanshu, Harish. Why, guys? Are you? Is it trailing? Come to everybody. Press on that live and stay live so that we don't have to wait longer. Right? Press on that live button and stay live intact. So don't be 2 minutes behind, 3 minutes behind. Right? Then we'd be kind of basically losing time. So you'll be still typing, but then I have to wait for 1 or 2 minutes to get your response. Right? Otherwise, few seconds delay is always there between the speaker and the response. Good. All right. Now let's, therefore, answer is simple. So therefore, you come back, answer this particular question. You say that, hey, there are nine x's and you have three, right? Therefore, three y. Sorry, there are three y's, nine x's and three y's. And hence you look at this nine and three. You say the required answer is 12 factorial divided by 9 factorial and 3 factorial, which is nothing but 12 into 11 into 10, because 9 factorial gets cancelled, and 3 into 2 into 1. We can simplify this, or let this is 6 2 times, and hence the required answer is 220. Answer is 220 for this particular question, right? So if you want to be calculated, calculation is not a problem. Writing this is not a problem. Once we understand that, hey, there is an inequality which is given to me, I'm converting the inequality to equal to sign by using the dummy variable. That concept is clear. Solving is not a problem. Okay, so now let's take a look at the cat question as it is. This was one of the cat questions as it is. Okay, I will give you good 2 minutes time. Everybody think about this. The reason I gave that previous concept was to enable you to solve this cat question. This is the cat question printed as it is. This appeared as it is in cat. Yeah, go ahead. Everybody use this 2 minutes. Use your pen, use your paper, and get me the answer to this question. Go ahead. If you use the understood the concept, solve it. Write the correct equations. Simplification might take some time. Okay, from simplification perspective, I'm extending time by 1 more minute. I'm sure concept is not the problem. I'm extending time for all of you by 1 more minute, because yes, simplification might take some time. And since we are learning, putting it to the concept also takes time. But in the exam, 2 minutes is the appropriate time for this question. Hmm. All of you guys, I'm hoping you're all sitting with a book and pen, not just watching the screen. Gandhi Jayanti holiday doesn't mean that you give a holiday to your brain. If you're working, let's work. Hmm. Good, very good, very good, very good, very good. Right. So answers, yeah. Now I got some good number of answers. Makes sense. Very good. So one way of looking at this, right? So this equation is technically, if you want to write it, yeah, good. Listen, guys, everybody listen. So I am sure all of you would have written it. Only calculation might be taking time. Is equal to 16. This is one case I should solve, right? X1 plus x2 plus x3 is equal to 17. That is the second case I should solve. Likewise, I may have to solve fifth case where I would be writing x1 plus x2 plus x3 is equal to 20. Technically, it is kind of solving about 5 cases. That is one way of dealing with this. The other way of dealing with this is what I want from 16 to 20. So one way is, hey, let me identify the solutions till here. X1 plus X2 plus X3 lying up to 15. Lying up to 15 from 0. Let us understand that in how many cases, they assume that these are the three people, X1, X2, X3, giving 15. All right, up to 15. That is one. And then I'm saying that, hey, from here, I will write another one where X1 plus X2 plus X3, all right, they would be getting up to 20, right? So 0 to 20. Now these are two cases. So this is solid, this is solid, this is the mass. Let's say this is case 1 and this is case 2. Solution to case 2. Required answer is case 1 minus case 2. What is the required answer? Case 1 minus case 2 is the answer. I need to identify the answer to case 1. So this is my case 1 and I need to identify the, because I cannot find an answer between 16 and 20. If I want an answer between 16 and 20, I need to carry out this 5-step process. But if I don't want to calculate that 5-step process, what I'm saying is, hey, I am going from 0 to 20. I'm finding distribution up to 20, out of which till 15 are not in my favor. Till 15 are not in my favor. 0 to 15 are not in my favor. From 16 onwards are in my favor. That is 16. 16 onwards are in my favor. How do I get that? 0 to 20, I find a solution. I will subtract 0 to 15 out of this. That is what I do, so that I get the solutions from 16 onwards. That is the approach to this particular question. How do we do? Therefore, introduce a dummy variable. You say that x1 plus x2 plus x3 and a dummy variable will be equal to 20, because we already learned this concept. Hey, if it is tagged between 0 and 20 and if there are inequalities, how did we say? Just put a dummy variable and equate it and solve it. This is case 1. This is the result to case 1. What about the case 2? Again, introduce a dummy variable x1, x2, x3. Okay, you want to write introduce dummy variable, put n, because you may say that d I already wrote here. I want to write another dummy variable or some same dummy variable. Doesn't matter. So just all it is equal to 15. Now these are the responses. Okay. Therefore, what is the answer to the case 1? 15 instances, 16, 17, 18. You say on one hand you got to calculate 18C3, on the other hand 20, 21, 22, 23. On the other hand you are calculating 23C3. So case 1 is 23C3, case 2 is 18C3. The difference is nothing but my answer. So of course, so therefore 23C3, 18C3 might take some time, because you have to multiply the numbers by 23, 22, etc. It does take some time, I understand. So, but then, yeah, this is what the expected calculation is: 28C3 minus 18C3, which yes results in 955, which is right. But did you understand the logic, guys? Have you reached this part clearly? Others, those who gave the answer, fine. I'm pretty impressed by that. What about others? Others, you understood this? Response is 20C3 minus 18C3. Did you follow my explanation? Is this clear? Is it lucid? Is this clear to everybody? Did you follow this? Everybody followed this, right? This was a cat question which appeared as it is. Clear? All right, many questions have come. I just simply pick few questions, because we can't solve all questions which come in cat on that concept. That's not the idea. Some questions where there are certain varieties which helps us, we can pick and we can discuss. It's not about solving all cat questions. That doesn't make sense. That doesn't make sense, because after a point they don't add any value, because it will be repetitive. It will be simply repetitive. The idea is not that the same question is going to come in cat again. No, it's a concept. Basically, we are identifying few questions from cat, so that we are identifying the concepts and we are well versed with the concepts. That's the idea. Okay, good. That's fine. All right, you understood this. Pretty good. Pretty good. All right. Okay. Yeah, small variation to the previous question, right? Small variation. Same thought. Let's continue with the same thought. Yeah, everyone, try and understand what this question is. Take a minute. Take a minute. Everybody take a minute and try and see what it is trying to ask. How do we represent this thought? All right, I'm extending time by a minute because calculation might take some time. Go ahead and answer. Right. Okay. Good, guys. Let's take a look. Let's take a look. Let's try and solve. First of all, right, he says that, hey, every child, it's given that every child, each child receives an odd number of marbles. In the sense, when I'm writing A plus, first let's understand what do we mean by every child should receive odd number of marbles. This is not, this is fine. So somebody got 3, somebody got 5, 5 plus 3 is 8, and therefore the other child is getting 7. This is fine. This solution is fine. What is not fine? I can't give you this solid 10. One fellow got 10, one fellow got 2, the other fellow is getting 3. No, this is not allowed. Nobody can get even number of marbles. Every child should get an odd number of marbles. Kind of a case like this, solid 3, 5, 7. This case is fine. You can't give a case like a 10, 2, 3. No, that is not allowed. That's very clear. Every child should report an odd number of marble. Every single child should report an odd number of marbles. So how do you write an odd number? Any odd number, first math, any odd number can be either written as 2n plus 1, or you can also write it as 2n minus 1. There are two ways of writing an odd number. Right? Similarly, even number can be written as 2n. That is the first thought, because how do you represent mathematically an odd number? This is a mathematical representation. Either I can choose to represent like this, or I can choose to represent like this. There is a choice. So which one to take, it depends on what I'm expecting, right? So there is nothing right or wrong. Should I use this or should I use this? So it's a convenience. Solid. Sometimes 2n minus 1 is convenient. Sometimes 2n plus 1 is convenient, right? So therefore, in this case, 2n plus 1 is convenient. You may wonder how 2n plus 1 is convenient. We will come to it. Now, I will write this as 2x plus 1. A gets number of marbles, which is a function of 2x plus 1. That's the marbles that I give it to A, because A should be odd. My math will not understand A is odd, but if I write 2x plus 1, the math will understand. A 2x plus 1 is always odd, irrespective of the value you give it for x. 2x plus 1 is definitely going to be odd. So for B, I will write it as 2y plus 1. So B gets 2y plus 1, whatever the value that you plug for y. So 2y plus 1 always is going to be odd. So C, I'm going to plug this as 2z plus 1. This is what I'm going to give it to C. Okay, sum of this is nothing but 15. Of course, now 2x plus 1 is an odd number, 2y plus 1 is an odd number, 2z plus 1 is an odd number. Sum of three odd numbers is going to be 15, irrespective of x plus x, y, and z. Okay, from here, let me take these ones to the other side, because it's an equation, right? It's an equation at the end. So take these ones to the other side. 1, 1, 1, you reduce it. So that becomes 12. It's a math. I'm doing a math here. So therefore, now you are ending up with a situation of 2x, 2y plus 2z is equal to 12. Why 12? I reduced this one to this side. I took this one to the other side. I took this one to the other side. Therefore, it got reduced to this. Now, take 2 common. Take 2 common. Therefore, you can write this as x plus y plus z is equal to 6. What did I do? I took 2 common and then I wrote it as x. All right, I took 2 common and I wrote this as 12. From there, we simplified it and we said that it boils down to x plus y plus z is equal to 16. I'm only modifying this. Now, you may wonder, can x be 0 here? Of course, yes. All right, that's the reason I took it as 2n plus 1 format. Reason being, now I can make x 0, I can keep y 0, I can keep z 0, meaning, hey, I will write x 0 here. Fair enough, a still takes 1. In that case, a would be still taking 1, because 2 times of 0 plus 1, 0 is allowed. But if I am writing 2n minus 1, the minimum value of n should be 1. Minimum value of n should be 1. So otherwise, I will get the negative value. The minimum, if the value of n becomes 0, then somebody will get -1 marble, which is not solid, which is not additive, which the marbles cannot be distributed in negative sense, right? And hence you say that, hey, I took 2n plus 1. Reason, I could see that, hey, I can make n 0 here. Making n 0 here is allowed. I can make this 0 here greater than or equal to 0, and hence I wrote in that particular sense. So therefore now I would solve this particular equation. Hey, 6 here, and there is 6 instances, 7th one and the 8th one. Therefore you say that the required answer is 8C2, which is 8 into 7 divided by this, which is 28. There are 28 ways of distributing 15 marbles among 3 children such that each one receives odd number of marbles. Is the calculation clear? Did it make sense to you? Understood? Everybody understood? Everyone understood what I tried to explain? Confirmed? Did it make sense to you? Put up in the chat, put it up in the chat. So if any point needs to be re-explained, let me know. Otherwise, I'm assuming that, okay, you are clear what I meant. Right? Good, good. Right. Very good. Very good. That's a good response. That's very smart. Nice. All right. So here we go. Your time. Now I'm expecting that. So within 2 minutes, everybody will answer this question. There should be no reason why you don't answer this question. If the previous question is clear, this should be answered. 2 minutes is a good time. So I want an answer in 2 minutes time. I want answer from each one of you. On the similar lines of the previous question. Go ahead, everybody try this. Very good. Very good. Still, if anybody is getting the numbers, put it up. Harish, if the coefficients are not same, we did it in algebra. Watch that on SC, the special class. Right? Coefficients are not 1. Right? If the coefficients are not 1, we dealt that in algebra. Okay? Watch that particular video. So that will answer it. All right? That we did in algebra in the special class under inequality. So you find it there. Right? You find it there on the app. You watch there we are talked about the different coefficients. All right, let's come in here. Your answers are good. Very nice. This is very nice. So what you answered, all of you, I'm hoping that everybody got the answer. Nevertheless, let me just take time to solve. A plus B plus C is this. I said that, hey, every child should get even number. So therefore, first fellow will get 2x. You say that B gets 2y, C gets 2z, all right, which would be equal to 22. Say, all right, now A can be written as 2x, B can be written as 2y. So C can be written as Z, all this, all it. Then we said that X plus, from here you write it, X plus Y plus Z is equal to 11. But author said, hey, look, don't send them empty handed. At least 2 marbles. Every child should get at least 2 marbles, which means the value of X should be minimum 1, not 2. It's 1. Because what A gets is 2x. So therefore you don't have to say that the value of X should be 2. No. Value of x need not be 2. The value of x has to be 1. And hence you say that this is not in the original form. And hence you say x plus y plus z is equal to 8y. You give 1 to x, 1 to y, and 1 to z and bring it to the standardized format, standard structure. Now work on this 8, there is a 9 and there is a 10, and hence your answer is 10C2, which is nothing but 45, which everybody got it right? More, all of you got it right. Now I have a question, teaser question to start with. I have a simple teaser question to start with. What is this answer to this particular question? All of you think about it and let me know what is the answer to this question. When three identical dice are rolled, find the total possible number of outcomes. What is the answer to this question? Go ahead, guys. I want the answer. Simple question. When three identical dice are rolled, find the total number of outcomes. You can put the answer in the chat. Good. When three dice are rolled, the total number of outcomes. I'm waiting for others. Harish, Ritvik gave the answer, Devanshu gave the answer, Srishti gave the answer, Rishav, okay. Others, that's the answer. Okay, before this, Ritvik, all right. Let me ask a question. Let me make it even more simpler, right? Even more simpler. When two coins are tossed, everybody answer. Listen to this. I don't have to write this. Just listen carefully and answer this in the chat. When two coins are tossed, total number of outcomes. Quickly. Two coins are tossed, total number of outcomes. Two coins are tossed, total number of outcomes. Put it in the chat. It should not take much time. Very spontaneous answers are required for this. Two coins are tossed, total number of outcomes. Don't say that you didn't teach this. I said that pre-reads will cover all of this, right? Okay, very good, very good. Okay, stop this. When three coins are tossed, total number of outcomes. When three coins are tossed, total number of outcomes. Quick, spontaneous answers. When three coins are tossed, total number of outcomes. Why only three people? Devanshu, Ritvik, Harish. Only three of you know, others don't know. So when three coins are tossed, total number of outcomes. Very good. Now listen. So when two similar coins are tossed, total number of outcomes. When two similar coins are tossed, total number of outcomes. Think carefully. When two similar coins are tossed, total number of outcomes. Same or different? When two coins are tossed, it is 4. When two similar coins are tossed, outcomes. Think and put it in the answer. When two similar coins are tossed, total number of outcomes. Same. Right. Listen, everybody listen. Now stop typing. Everybody stop typing. Even if you are getting an urge to type something, don't type. Listen. All right, there is something I need to update here. Listen, everybody listen. Assume that I have everybody listen now. Now don't type. Nobody type. First listen. Okay, yeah, there are two coins. Assume that I have one 1 rupee coin and one 2 rupee coin. I'm here on my study table. I have one 1 rupee coin, one 2 rupee coin. So or you have the coins. Let's say that, okay, you have the coins, right? And then you toss the coins. I'm here. I'm recording it here. So I'm here and you are on the other side. So you type that particular coin. And let's take Harish as an example, right? Harish has tossed at his study table and he tossed both the coins. So now he has one 1 rupee coin and one 2 rupee coin. Now you may say that, sir, why not my name? Take any name, take you only as an example. You toss two coins and you said that both are heads. I will not ask Harish anything because he said that both are heads. I will record it like this. I just record it like this because he said both are heads. Okay. Then again, I asked him, repeat the experiment. He again tossed both the coins and he said that, sir, both are tails. No problem. I will record it. I will not ask him anything. Now again he tossed and he said that one head and one tail, right? He said one head and one tail. Now I will not record whatever I feel like. I cannot write head and tail because head on the one coin is different from getting the heads on the second coin. Right, because he said one head and one tail. Getting head on the 1 rupee coin is different from getting head on the 2 rupee coin. I will ask him, Harish, which coin has given the heads? When earlier Harish said that both are heads, I won't ask him anything. I will simply record my observation. Both are tails, I don't ask him anything. I will record those observations. But when he said that, sir, one has given heads and one has given tails, I will ask him, where should I write this head? Should I write head under 1 rupee coin? Should I write head under 2 rupee coin? Because you said one head and one tail. How I should be writing this? Okay, so therefore you said, hey, these are the 4 outcomes. Those who said that, so when two coins are tossed, there are 2 outcomes, correct? There are 2 outcomes, that is head or tail, and hence you said that totally 4 outcomes. I showed it to you. Instead, now Harish says that I said that Harish, take 2 coins. He said that, sir, I have 2 1 rupee coins printed by the same RBI, same year. They are looking same. I said, okay, no problem. Take the same 2 coins and toss me. So he has 2 1 rupee coins with him now. 2 1 rupee coins, ditto. Nobody can identify what is the difference between them. They are looking same, printed by the same RBI, same year, same batch. Everything is same there. Okay, fair enough. Now he's throwing them. He says both heads. I don't ask him anything. He says both tails. Still, I will not ask him anything. He says one head and one tail. I will still not ask him anything. I will still won't ask him anything. Why? He himself cannot distinguish which coin is what, because both are 1 rupee coins. When he says one head and one tail, I write like this. If he says that, no, sir, you write head that side and this side, how will it make a difference? Will it make a difference? Is it a different coin? You yourself can't identify the coins. How does it make a difference here? And hence, here there are 4 outcomes. Here there are 3 outcomes. Guys, did you understand this? Did you understand this? The coins are similar. The coins are similar. The coins are distinct. There is a difference. There is a difference in the outcome, recording the outcomes. Did you understand this? Is this clear to you? Is this clear to you? Everybody, is this clear? Right? Because a lot of people get confused the moment the word similar comes. Hey, outcomes change. Outcomes change. So whenever somebody says that 2 coins are tossed, the hidden understanding is they are distinct. Tacit understanding, unsaid understanding. I met 2 kids, which means they were looking different. If they are looking same, then I will tell you. If it is not, I don't have to tell that. All right, I don't have to tell that. Okay, I said that, okay, hey, I stepped out and I met 2 kids. So fine, which means I can identify who is who. I can identify them. I'm not thoroughly confused, which means next time you show them, I will identify, yeah, this kid is different from this particular kid, right? So that's what it means here, right? But which means I don't have to tell I met 2 differently looking kids. Hey, I met 2 kids. So if it is very different, in the sense, hey, exception, I met 2 kids, I just couldn't identify differences between them. I was thoroughly foxed, confused. Then I will say, hey, they were so similar, man. They were so similar. Then I will add that word. Otherwise, it's understood to be distinct. When 2 coins are tossed, meant to be distinct. When 3 coins are tossed, meant to be distinct. If it is similar, I will tell you. If it is similar, I will tell you. Understood, my friends? Everybody understood? Everybody understood? Watch out for this similarity, etc. Watch out for this. Alright, you got to watch out for this word. You got this? You got this? Clear? Clear? Everybody clear? Everybody clear? Now will you tell me, when 3 similar coins are tossed, what is the total number of outcomes? Could you quickly work on this? When 3 similar coins are tossed, what is the total number of outcomes? When 3 similar coins are tossed, what is the total number of outcomes? When 3 similar coins are tossed, what is the total number of outcomes? When 3 similar coins are tossed, what is the total number of outcomes? Right. 4 is correct. 4 is correct. Very good. 4 is correct. Right? 4 is correct. Simply put, what do you say here? Alright, now how did you get this 3? Hey, both heads, 2 heads, or 2 tails, right? 2 tails, or 1 head and 1 tail. That's it. 1 head and 1 tail. That's all the breakup is. Similarly, 3 similar coins are tossed, all 3 heads or all 3 tails, or you say that, hey, 1 head, and the remaining 2 tails, doesn't matter which is that, and two heads, and the remaining one is tail. That's it. These are the only four outcomes. These are the only four outcomes. Okay, now question is, when two similar dice are rolled, let's come to this point. When two similar dice are rolled, what is the total number of outcomes? When two similar, when nothing is mentioned, it is different. I already told you, Mr. Agarwal, right? When nothing is mentioned, it is meant to be different, right? I already told you, it is distinct. Okay. If it is similar, then I have to inform that. Okay, when two similar dice are rolled, total number of outcomes. When two similar dice are rolled, total number of outcomes. When two similar dice are rolled, total number of outcomes. Hmm. Right? Okay. See, when we were distinct, your teachers asked you to write like this. So assume that D1 is different from D2. Assume that there were two distinct dice. D1 is different from D2. Assume. So this is how your teachers have asked you to. Okay, we don't do this. I'm coming to that. Okay, after doing all this, what? We will see. We will see. All right, we'll come there. We will come there. So assume that these are distinct. Then your teacher said that, hey, 1 1 here. You write 1 2 here, 1 3 here, 1 4 here, 1 5 here, 1 6 here. Then 2 1 here, 2 2 here, then you write 2 3 here, 2 4 here, 2 5 here, and 2 6 here. Right? Likewise, you go ahead and you write it as 6 1 here, 6 2 here, 6 3 here, 6 4 here, 6 5 here, and 6 6 here. The moment I make them same, 1 2 becomes same as 2 1. 1 2 and 2 1 remain same. Now these two becomes equal. 1 2 and 2 1 are same, right? Because why? Because they are same. Earlier it was different. D1 was giving you 1. So here D2 is giving you 1 because D1 and D2 are two differently looking dice. Maybe the color variation, the size variation, you can identify. That is what I mean by D1 and D2. You are not confused between the two dice. If I mix them and show that which was this, which is that, you say that both are same. No, you are not saying that. You can identify them. When you used to identify them, 1 2 and 2 1 are two different things. Solid, no, they were two different things, but the moment is, hey, D1 is D2, both are same. If I change them, both of them are similar, then you say that, hey, these two are equal. Now the moment I do this, these two are equal. Therefore, what do you say? So along this diagonal line, either count 1 2 or you count 2 and don't count both of them. So and then you say that, hey, there are 36 elements. Out of 36 elements, 15 are this side, 15 are this side, and 15 are on the other side, which is a duplication, and 6 of them lie on the diagonal line, 1 1 2 2, like this, 6 6. 6 of them lie on the diagonal line. That is the breakup, right? 15 are one side of the diagonal line, the other 15 are another side of the diagonal line, and 6 of them lie on the diagonal line. Therefore, what I need to count? Either count this 15. If you count this 15, then discard this 15, but count these 6, because these 1 1 2 2 3 3, these numbers are different. So 15 plus 6, you could say that my answer is 21. Did you get hang of this? Are you understanding the difference between similarity and different? The dice being similar and dice being different will make a difference to answer options. Are you noticing that? Is this clear to you? Is this clear to you? Everybody clear to you? Is everybody clear? Quick guys, quickly respond. Is this clear? Simple concept. First, we need to understand that it is different, because a lot of people tend to believe that similar dice are different dice, everything is same. No, it's not same. First, we need to understand that they are different. That's the first thing. Different and similar are two different worlds. Okay, yeah. Now let's come back to the question. Now, having understood this, now let's be back to the question. How do we approach this? So we are back to the question. This is a background to this question. What I did so far, I gave a background. When three identical dice are rolled, find the total number of possible outcomes. This whole story was to solve this question. That was the whole story. The story was about solving this particular question. Now think about it. Everybody think about it for a minute. How did we consolidate this? How do we go about this? How do we go about this? I'll give a minute. You answer or not doesn't matter, but think intensely about this. What is this fact is all about? Okay, now listen, guys. Listen, let me go back to the coin. Listen, it's okay. It's okay. Just a thinking time, right? Solving time is different. Thinking time is different. Okay, first listen, guys. Let's listen this. Hey, when four identical coins are tossed, when four similar coins are tossed, let me come to four similar coins are tossed. Let me say that. How did I identify this? It was simple like this. Hey, what are the two outcomes possible? Head and tail. Head and tail. The breakup of head and tail should be 4. That's it. Give me any breakup which is 4. Hey, can I say that 4-0 is a solution? Yes. Yeah, 3-1 is a solution? Yes. This is what you said, right? 5 solutions. Answer is 5. Listen, everybody listen carefully and we'll close with this understanding of this concept. Head plus tail is equal to 4. So 4. So what is that you are saying? You tossed 4 similar coins. 4 similar coins you tossed and you just have to give me the breakup. All 4 heads or 3 heads and 1 tail, 2 heads and 2 tails, or you will say that okay, 1 head and 3 tails, or 0 head and all 4 are tails. This is what you meant by 5. Your answer is 5. 5 is the answer. How did I get this? Very simple. So I would put like this. Okay, there are 4 x's with me and there is one y here. 4x and 1y together I have 5 objects. 5 factorial divided by 4 factorial and 1 factorial, nothing but 5. This is the answer to this. How did I solve that dice question? When two similar dice are rolled, just like the way you wrote the outcomes, write the outcomes. Outcome can be 1, outcome can be 2. O2 means outcome can be 2, outcome can be 3, outcome can be 4, outcome can be 5, or outcome can be 6, right? Outcome can be 6. Now all these 6 outcomes put together, it should be breakup of 2 coins, 2 dice, because I rolled only 2 dice. I'm asking for these 2 dice. What you can say? You may say that, sir, one of the dice has shown the 2 up, the other dice has shown 4, which means there is no 1 as the outcome, 3 as the outcome, 5 as the outcome, 6 as the outcome. I'm just writing a possibility. You rolled 2 dice and you are saying that, hey, one of them has shown 2, one of them has shown 4. Which one has shown 2? That you can't answer because they are similar. Okay, what if all it now you may also say that, sir, both are showing 3. Okay, if both are showing 3, then nothing is showing 4 up, nothing is showing 4, 5 up, 6 up, or 2 up, or 1 up, because both of them are showing 3 up, right? You may say that, no, sir, one of them is showing 1 up, one of them showing as the 1 as the outcome, the other one is showing 6 as the outcome. So naturally, there is no die which is showing 2, 3, 4, or 5 as the outcome. So therefore, I'm saying that, hey, how do you break this 2 into this? That's all the simple out here. Okay, therefore, you say that, all right, man, I have 2 x's. So y is your 1, 2, 3, 4, 5. I have 5 y's together. I have 7 objects. Answer 7 factorial divided by 5 factorial and 2 factorial. This is what you gave as the answer, which is 7 into 6 divided by 2. All right, which is nothing but your answer 21. This was the answer to earlier question. Precisely. Now in this question, everything remains same except that this number 2 changes to 3. This number 2 will change to 3. Therefore, instead of this 2x, you will be writing this as 3x, right? This 2 changes to 3. Everything remains same. Therefore, this 7 would change to 8. 8 factorial divided by 5 factorial and 3 factorial. Therefore, 8 into 7 into 6 divided by 3 factorial gets cancelled, and hence your answer becomes 56. Did you all understand this? How we use this concept in the similarity of dice, coins, whatever it is? Got this, my friends? Everyone clear? Everyone clear? So why I am discussing under this concept, that has to be clear. Why am I discussing this question under what we are learning? Because we use this concept to resolve the similarity of dice and coins. Understood? Everybody understood? I hope everybody understood this. I'm hoping that you understood. Otherwise, this last question, take a look once again at later stage. Don't get confused. Okay. Devanshu, Sumit, Ritvik, others are still struggling to understand. Others are still struggling, taking some time. Rishabh, then if it is not similar, you don't need this. No, what if I would have thrown three distinct dice, right? Three distinct dice. You already know. You all guys answered that D1, D2, D3. You said that these six are different from these six, different from these six. You said 2 and 6. Why do you need a concept for it? You already knew that, right? This is only for similar you are asking. Of course, yes, right? Because for a different, you already know. Different is dealt in with a different model. Similar is dealt with a different model. The models are different based on the questions your counting algorithm will change. What we are trying to learn? We are trying to learn counting. Counting depends on the kind of objects we are using, right? So we don't use the same algorithm to count everything. So counting method changes based on what my objects are. I mean, what my objects are means, are they similar? Are they distinct? This is the first classification. It's the first classification. Priyanshi, what do you mean by what are identical dice? Identical dice means they look same. Otherwise, one die you can have a red in color, the other die would have painted, or dice can be painted in blue in color. You can identify, or one can be big, one can be small, right? When you are having the dice on which 1, 2, 3, 4, 5, 6 are printed, they need not be of the same size and same color, right? But they can be of the same size and same color as well. Yeah, Devanshu, what if they are similar and different? Work out, work out. You know how to work on the different. You know the model for this. You know the model for this, right? You know the model for this. Use the combination of models. I gave both the models. Now you work, right? Now you work. That's a part of your combination study, isn't it? That's a part of your combination study. That's another study altogether. That's a 1 hour study. So there are four fundamental things in the combination. Once you get those four fundamental things, use this concept along with those four fundamental things, you will be able to get the answer, right? You can't do it directly just by knowing this. So you got to know those four parameters. Along with that four parameters, you got to use this, right? That's a combination study. First, you should study combinations and use combinations along with permutations, because what you are doing here is a permutation. Use combination with permutation to answer your question. Okay, yeah, great. All right, guys, that brings us to the end of today's study. That's pretty much. I hope everybody learned something. Can I know how many of you have learned something through the discussion? Let some learnings here, some learnings, everyone. Yeah, it would be confusing, right? Rishabh, don't worry. Counting is always confusing. Even to me also, it's confusing. Counting is confusing, no doubt about it, right? But we will study to get as much clarity as possible. That's it, right? Nobody can claim that it is not confusing. It is confusing. Counting is bit confusing, but we learn so that we will minimize that confusion, right? Minimize that confusion. That's the whole idea there. All right, guys, tomorrow being Sunday. So, tomorrow being Sunday, you guys take a mock. That's important. So, all of your focus, attention should shift to mock first. Then I will see you guys on Monday at 4 p.m. and 10 p.m. So, once the sessions are plugged in, you will be able to see what sessions we are doing on that particular day. That's pretty much about the upcoming lectures. And if you have liked what we are trying to do, so you can always type in the like before you leave this particular session, share the link with others, and then so log in, jump on to the Telegram group in case you want to understand what we are trying to do into the future, or some discussions. Yeah, that is pretty much. So happy learning. So all the best. Do well in your tomorrow's mock. Okay. So I will see you guys back on Monday. Bye till then. Stay blessed. God bless you. Yeah. Any short comments you can put it now. I will watch it. All right. Looks no comments. I will stop here. I will see you guys back on Monday. Bye bye.